so we actually had a very light start, so you can digest what is called native, what is Kubernetes, what is, how to deploy Kafka. Now we're gonna go more deep into cloud native, technologies, and it's gonna be a little bit more advanced. And we're gonna finish the day with a super advanced talk on security. As Victor said, security always is the last, and in our conference we're gonna have 4 talks about security as the last talks, basically. But this is gonna be I think the most interesting, because we know a lot of companies already using Kubernetes, but they need to make sure it's secure and using cloud native as well. So please stay tuned. And if you have any feedback, please find me and talk to me. I'm gonna be always happy to talk to you. All right, so I would like to invite our next speaker, Syed Ahmed from CloudOps Solution Architect. Thanks for coming, Syed. And thanks everybody for standing ovation. We really appreciate that, especially the day is long, so some exercise is always good. I would pass the mic to you, Syed. I'm really looking forward to learn about doing machine learning on Kubernetes.
Thank you very much, Ed. So I'm just going to follow wiki step and start my timer. All right, good morning, everyone. My name is Syed. I'm a solutions architect at CloudOps, mostly focused on big data and machine learning problems. So it's an interesting thing how CloudOps is sort of getting into the big data and machine learning. From the looks of it, we do cloud and operations, so it's really a new field for us. So I'm going to start off with sort of giving you an idea of where machine learning is right now. You might have already known a lot of use cases already, so things like self-driving cars, we are doing automation, IoT, blah, blah, blah. I will give you some interesting ones that I found. So machine learning is being used to now flip burgers. They developed this robot which can flip burgers, and then it has sensors. It has it can track burgers around the stove and then flip them when they're cooked. So all of that is being enabled by a machine learning algorithm. They put this robot in a restaurant, and it flipped burgers so fast that people were not able to keep up, so they had to remove them. Now there's another interesting field called computational gastronomy. So this is another interesting field where they're applying machine learning to better develop sort of food, I guess. So one of the interesting projects here is something called Bittersweet, which will use machine learning to predict what kind of bittersweet products are good for you. And there's IoT mining. So this is another interesting use case where they're using like smart caps, or they're putting webcams on top of heads of miners. And if the miners bob their head in a certain way, that means they're tired. So there's a machine learning algorithm that detects that. And when a worker is tired, they pull him out of the line. And all of that is, again, facilitated by machine learning. And finally, saving the rainforest. So this actually is a project from Google, and using TensorFlow. So they developed like machine learning models which can detect sounds of like logging or people doing like burning the forest, so they can detect that and they can alert the authorities. So it's a really, really interesting use case. So I guess the point I'm trying to drive home here is that machine learning is going to be everywhere, and it's inevitable. So now we come to why cloud native and why Kubernetes and machine learning. So if you look at it, machine learning jobs or machine learning workloads tend really well to containerization. So, and Kubernetes is the platform to do containerization or run containers. The idea of using containers for machine learning is because containers sort of encapsulate everything that's required to run a machine learning job. And if you're running machine learning jobs, you will have a fleet of machines doing training, inference, and a lot of other data processing. So it requires a lot of operations. Now, traditionally, your operations and your development were separate, and if something went wrong in your machine learning job, the operation guys had no clue. Right now, by using Kubernetes, what you can do is you can sort of have this segregation where operations guys are only responsible for maintaining the state of the Kubernetes cluster, and they don't have to really understand what's happening inside, because everything, again, is so encapsulated and tightly knit. Now, again, because of Kubernetes itself, we can chain containers, and one action of one container can sort of trigger another action. So this is, again, only possible because we're using sort of a cloud-native model. Scaling is also another thing. So if you have inference model, which suddenly requires a lot more CPU or GPU capacity, you can just scale it up. You can give it more resources. You can have more replicas. You can do that with Kubernetes very easily. Now, coming to Kubeflow. So, Kubeflow was a project started by Google. The idea was to have a composable, portable, and scalable machine learning. And basically, you can think of Kubeflow as an umbrella project. So it contains a lot of small little projects which come together and sort of interoperate again in like a more cloud-native way. So here's a bunch of projects that are inside the Kubeflow umbrella. So the first one, and the sort of the stem you can see of the umbrella, is TensorFlow. That's keeping the whole structure together. So TensorFlow is a machine learning platform. It basically provides an easy-to-use API for doing machine learning, highly focused on deep learning, I would say, but you can still do traditional machine learning using TensorFlow. The next one is JupyterHub. So JupyterHub is more of a collaboration tool between different data scientists or developers that are running machine learning jobs. So what JupyterHub gives you is a web interface where you can put code and you can put documentation and you can see why, or you can basically collaborate with different people, and you can also do things like you can plot graphs there. So you have your code there, you just change your code, and then you can see the data in real time. So it's really useful. Now, the TensorFlow introduces custom resources for TensorFlow jobs. So if you've ever worked with TensorFlow or distributed TensorFlow, you know how hard it is. So things like if you have, let's say, a cluster of 5 nodes in TensorFlow, all the 5 nodes should know about all the other 5 nodes. If one of the nodes go down, you will have to update all the other nodes that node is no longer available. It was very, very complicated. With TensorFlow, what they have done is they've sort of operationalized everything. So instead of updating all the nodes with what nodes are available, you just update a config map and it gets populated everywhere. So things like that have made doing distributed jobs very easier. In this example, you can see how easy it is to, for example, if I want to scale my masters or if I want to scale my workers, you just change the number there. It's like a kubectl edit, so it's super fast. The next one is a hyperparameter tuning framework. This is for if you're doing any machine learning, you do a lot of tweaking around your model to get the best accuracy. So this framework called Katib is included in the Kubeflow projects, which you can use to sort of automatically tune your machine learning model. And finally, for serving, they support a bunch of serving platforms. The most notable ones are Seldon. This one is TensorFlow serving, and TensorRT. So TensorRT is a proprietary sort of serving platform or inference platform from NVIDIA. Now, they introduced something called as ML pipelines last year. This is another interesting use case where you can design reusable pipelines. So if I'm a data scientist, I can basically design a pipeline, so I can say output from this block should go to the other block, and I can share my pipelines with everyone. So in that way, what you've done is, if you are another data scientist and you want to work on my project, I just share my pipeline with you and the raw data with you, and that's all you need. So we can, I will show you a demo of this real quick. So let's, this is a customary slide I include in every presentation of mine, and it actually works. Cats and gods. So the demo is going to be quite simple. We're going to look at the Chicago taxi cabs dataset. So basically, the dataset contains information on taxi rides that have happened in the city of Chicago for a particular year. Now, what we want is, once we analyze the data, we want to give my model or our model starting location, ending location, and the time of day, and the model should predict how much it's going to cost. So it's a simple use case. It's like an Uber use case. For this use case, we have about 1,000 training samples and about 5,000 evaluation samples. We're going to use TensorFlow extended, so it's TensorFlow with some added modules. So these are the bunch of added modules. So you use TensorFlow data validation for validating if the data is correct or not. If it's not, you basically remove bad data. Then transformations is where you take the data, you transform it into features that can be understood by the training algorithm, and then you train the model using TensorFlow. After the training, you can look at how much accuracy you've got. Do you need more data? Do you need to add more nodes to your neural net, or things like that can be sort of understood by using this module called TensorFlow Model Analysis. And finally, you can deploy it using TensorFlow Server. So in the interest of time, I actually have done this already. I'm going to show you real quick. Hello? All right. So now, the first thing you will do ever is to deploy Kubeflow. They've made it super, super easy to deploy Kubeflow now. So you basically just go to deploy.kubeflow.cloud, and you just enter a bunch of credentials. So by default, it deploys to GCP. You can deploy it on Azure and AWS, but it's not that easy. They put a high emphasis on it. I mean, for good reason. Most of the developers in Kubeflow are from Google, and that's the resource that they have. So it's basically super easy to deploy a Kubeflow cluster. You just enter all this information, and it will deploy a Kubernetes cluster. So when you deploy the Kubernetes cluster, what you get is a lot of these. So there's so many things that you get from just hitting this create deployment. Now, at the end of the day, what you want to go for is the dashboard. So that looks like this. So this is the main page of Kubeflow. So if you see on the left, these are the different projects that I was talking about. Notebooks, TensorFlow jobs. This is the hyperparameter tuning framework, and then there's finally the pipelines, which sort of ties all together. So let's look at the notebooks. So you can create new notebooks or new servers. If you want to add more memory, if you want to add more data or data disks, or if you want to add GPUs, you can do that here. It's very, very extensible. So imagine if you add 2 GPUs, it'll create a GPU cluster, and because it's using GKE, it uses auto-scaling, so that means when you're not running jobs that are GPU heavy, it will shut it down. So I have already created a Jupyter Hub server, so I'm just going to connect to it. Now here I have my demo. So this is basically a Kubeflow pipelines demo. Now, as I said, pipelines is a way for you to encapsulate or take your whole machine learning workflow from end to end. So basically taking it from raw data to serving sort of model. All of that can be done using basically just this. So if I zoom in a little bit, so what I'm doing here is basically I have for each of my sort of block in my pipeline, I have one image. So just to give you an idea of what the pipeline looks like, I can go here, open another tab. So what we are looking is basically trying to design the dashboard pipeline. Okay, so we are looking at this one. So here you can see a sample pipeline here. So what we're doing here is we're doing a validation of the data. If the validation succeeds, then we pre-process the data, some of the data we pre-process, and then that pre-processed data is going to go to training. And once this training is successful, you will do analysis, you'll deploy it, and you'll also run prediction on it. So this is sort of the pipelines that I'm talking about. You can create your own pipelines, and what Kubeflow gives you is an SDK to do that. So I'm just quickly going to show you that SDK. So that's basically here. So as I showed you in the pipeline, so each block in that pipeline is going to be an image. Now, there are default images you can see here that are provided by Kubeflow itself, but you can create your own images, which are very suited to your use case. These are generic images. You can use it for any sort of model which uses neural nets. Now, the way you sort of bunch all of these together is by going and doing something called as so you create two things. So the first thing you create is called an experiment, and then you create individual runs in the experiment. So here what I'm doing here is basically I'm creating an experiment. So if I click here, and I can just, for the sake of demo, I can do experiment name plus cloud native. So what I will get is another experiment. So if I go back to my Kubeflow dashboard here, if I look under experiments, so this is the experiment that I just created. So I have one already created from last night. So in the experiment, you can do different runs. So a run is basically a combination of parameters. So things like how many nodes you want, or how much of the data is going to be used for training versus how much data is going to be used for prediction. So things like that are different for each run. Now, once you create an experiment, you can use it to create different runs. So here, what I'm doing here is, if I just keep going down, I am creating a pipeline here. So the way I do it is by calling the pipeline param. So this is, okay, hold on, let me, all right, so here. So this is the pipeline, the whole pipeline. So the first step is validation. So if the validation basically calls this function, which at the end of the day, what this does is it creates a YAML file. So the validation is one step in the training. the output of the validation goes in the next step, which is the pre-process. So the way you do that is basically call validation.outputs, and then if there are multiple outputs, you choose one of the output. And the output of the pre-process goes in the train. So how do you do that? Pre-process.output. So in that way, what I'm doing here basically in this whole block is creating this kind of, creating this pipeline, this whole flow. So once I've created the whole flow, what I will do is, if I go back to my code here, I will submit the run. So what this does is it will compile all that flow into a tar.gz file, and then it will basically take that tar.gz file and push it to a container which will run this job. So at the end of the job, what you get is basically this flow, and the sort of the little check marks here are basically successful execution. So if something has gone wrong, you can retry it, and it works, and it's super flexible. So at the end, what Kubeflow allows us to do is basically build machine learning models or do machine learning using cloud native approaches. So with that, I will give back the time. And any questions? I have time for one, maybe.
Thanks, Syed. So Syed works with machine learning and big data at CloudOps. He's one of our smartest solution architects, PhDs, and many others. I mean, like, he's a super smart guy. I mean, like, when I see this much of code, you know, and like, it's for me, it's incredible. So thank you very much. I'm sure there's a lot of people who want to ask you questions. We can take maybe one if you have. Anybody? No? Actually, I have a small present. Stay thirsty, my friend. This is a Kubernetes bottle. Yeah, so thank you very much for coming, and I hope we'll see you around. Thank you.